Today we have organized a demo lecture to demonstrate the importance of CFD modeling. CFD is part of modeling and simulation. In engineering, we learn most of subject theoretically, but theory cannot be used for complex industrial problem, and experiment has limitation due to high capital investment. To reduce experimental cost and limitation of theoretical analysis, CFD modeling has been a very important role for analysis of various products related to the fluid flow, heat and mass transfer. The scope of CFD modeling is not only limited to mechanical engineering, but this course is also important for chemical engineering, aeronautical engineering, students from applied mechanics department, anybody who is working on fluid flow and its application, then this subject is very important. Even though those students are working on computer science, they would like to test their parallel software, then CFD has been very important subject. CFD is subject of to predict the flow physics with confidence, and many industry they are asking the job opening on CFD modeling or relevant job profile. All thing will be discussed in this lecture. Outline of this presentation is given here. First, we will understand what is a modeling and simulation. CFD is part of modeling simulation. Then we learn what are essential subjects for CFD modeling. And then we'll learn what are lectures are given in Advanced CFD course. There are 12 lectures on various engineering subjects. There are around 10 tutorials related to the industrial problems. Then we will discuss a registration of this Advanced CFD course. Then we will discuss career and job opportunity after completion of this course. Then most important thing, what are factors affecting job opportunity? How can you get an initial job? How can achieve growth in CFD job? What is your future after 10 years? Even though you may work for a long time. What we learn from Advanced CFD course, and then we'll cover one CFD tutorial based on battery simulation. First, we have to understand What is modeling and simulation? Modeling means mimicking the physical phenomenon with some other meaning. We are representing physical phenomenon with mathematical model, and these mathematical equations are described and solved at a large quantity, hence it is called as simulation. In school and college we learn most of theoretical subject. One of the example is mathematics. We learn all the formulae, example derivation, integration, partial differential equation, ordinary differential equation, solution of differential equation, but we don't understand how it can be applied to the practical problem. This theory is connected with physical subject in physics, and in physical subject there are a lot of formulae given in engineering subject, but we don't physically understand how this formulae related to our engineering application or real life. To prove the theory, we have to carry out experiment in laboratory. Theory can be applied to the simple problem, but experiments are costly and risky for complex problem. To prove a theory, we do lot of experiment in laboratory. Similarly, in industry, they have research development unit. There a lot of practical studies of their products is carried out to improve their efficiency, to improve performance. How can improve that product? There is always scope for research and development, but experiment is expensive. To reduce cost in 21st century, modeling simulation has become important. Nowadays, computer is affordable, software is also affordable. Even though using our laptop, you can use CFD software and simulate a real life problem. And CFD plays an important role to develop new product for industry or to predict the importance of a new product in future. And CFD is a virtual tool of research and development. Please note that it is a virtual tool of research and development. CFD is part of modeling and simulation to predict the flow over any body. Here I have given an example of flow over the aeroplane. To carry out test of this model, it will be very expensive, but using CFD simulation it will be easier. For modeling and simulation, it is depend on three pillars. First is applied mathematics, engineering and biological and physical science and computer science. And modeling simulation comprise problem formulation and analysis, followed by numerical analysis and programming. After programming and execution of program, we can visualize data using post-processing tool. To achieve post-processing and numerical analysis, computer science is very important. We need software, we need hardware. And CFD is part of the modeling and simulation. There are three important pillars of computational fluid dynamic. First pillar comprises physical subject like fluid mechanics, heat transfer, thermodynamic. There can be chemical engineering. Whatever could be, all subject comes in one pillar, and other subject like mathematics, because in CFD most of governing equations are presented in terms of partial differential equation. These equations may be completely differentiable. To find out solution of partial differential equation for mass, momentum and energy, numerical methods are implemented. What are numerical methods which are in mathematics? Example, finite volume method, finite element method or finite difference method. After converting into the last set of algebraic equation, this equation cannot be solved using by simple calculator or hand calculation. We need a programmable device which can compute a set of large equation using matrix method. And to run this program, we need hardware. Hence, CFD comprises three important pillars. Why CFD as effective tool for flow analysis? It has been used in wide range of industries like automotive, aerospace, power generation. The role of CFD is to design and optimization of industrial problems. Traditional design methods have limitation. They are based on formulation, and formula are based on assumption. Example, the formula of heat any correlation, example convective transfer correlation, is applicable for 2D flow, but this formula cannot be used for 3D application. Hence, there are lot of limitation of traditional formulation. To achieve to overcome this problem, CFD has become important role for design and optimization of industrial products. Previously, wind tunnel has been used to carry out testing of vehicle in automobile industry, space industry, but the cost of wind tunnel is very high, and most industry cannot afford this cost. To if you use CFD simulation, the cost will come down, and CFD simulation definitely will help to give better result at a low cost. What are advantages of CFD over the experiment? The cost of CFD is relative cheap. The time required for analysis in CFD is less. We can give a simulation for a single night, we can get result tomorrow. But in experiment, it is not possible. We have to be there. CFD can be carried out all scale of product from millimeter to the in meter. Size can be mm to the 100 meter. But experiment cannot be carried out for large devices like flow over the warship or a very big aeroplane, because it requires very huge space. Hence there are limitations in experiment. In CFD we can get data in all the point, but in experiment we get data only at major point, because we cannot put measurement devices at all the point to get the complete data, because there are limitation in purchasing of this product. CFD is repeatable, experiment is not repeatable all time. CFD is safe. You don't need to about any disaster, damage due to mishappening. In previous slide, we discussed what is modeling simulation, how it is related to mathematics, engineering subject, and computer science, and what are advantage of CFD over experiment. Those who would like to build their future in CFD is just tool of analysis, but we have to understand there are other subjects which are supporting the CFD analysis. That is very critical. Otherwise, the future of CFD job will not be the up to mark, or there may be limitation for job opportunities, because you have to learn how CFD modeling is important and what are essential subjects to learn it. It is an interdisciplinary subject. It is not all about CFD software. Anybody who knows CFD software doesn't mean you will be successful as a CFD engineer. Hence, we have to be familiar with the following important subject as per your need. First is the mathematics. In mathematics, you must be familiar with differential equation, integration, finite value method, finite element method, finite difference method. Those students who would like to learn only application related software, then they don't need to learn more about mathematics. Don't worry about mathematics. But at least some understanding about mathematics is important. What are differential equation? How they are physically interconnected? That is very important. And we have to understand which are physical quantity are conservative, which quantity are not conservative. That's also important to understand. And the second most, there are key subject you should understand both theoretically and practically. Fluid mechanics, heat transfer, thermodynamics. In fluid mechanics, there can be turbulent flow, turbulent modeling, reactive flow, single phase, multi-phase flow, turbomachinery, combustion, emission control. These subjects are vast. Third important pillar is computer science. You must know use laptop for learn when you are in learning phase. You can use personal computer when size of CFD simulation become large. If size of CFD problem is very high, like most of industrial problem, they need to use high performance computing machine. It is also called as workstation. And we can visit website CFD flow engineering. What is the requirement for CFD? What is the requirement of hardware for CFD simulation? If you want to do high-end research, then we need supercomputer. We have to be familiar with programming tool, C, C++, Python. This programming you have to learn if you don't need to use commercial software. If you are not comfortable in programming, we can use a ready-made CFD software like ANSYS Planet, OpenFOAM, StarSystem and COMSOL. In Advanced CFD course, we will be emphasizing on only these two software because learning one commercial software and one open source software is good enough. We should learn at least one software. You don't need to learn all the CFD software. Learn one CFD software thoroughly. That is good enough. OpenFOAM is tough unless you don't have programming skill. If you are very good programming in C++, then you go for OpenFOAM. The next, experimental data for validation. CFD result should be validated to build confidence. Otherwise, it gives colorful result which may be beyond reality. And to check it, experience matter a lot. Practical data may help to guide CFD. Hence, to build future, you must know engineering subject both theoretically and practically, as well as requirement of CFD software and hardware. And we have to also see the cost. the cost for commercial software is very high. Hence, to save cost, some industry are using open source CFD software. Please note that. Major application of CFD analysis. CFD has scope in automobile industry, aerospace industry, chemical, process, chemical, oil and gas industry, production and manufacturing industry. To control temperature, there is always scope for CFD. In turbo machinery, to design fan, turbine, compressor, blower, pump, CFD plays a vital role to understand flow pattern. Thermal and nuclear plant, CFD plays crucial role for optimization, where actual experiment is very difficult. Combustion, fire safety, environmental pollution, CFD plays a vital role. Many industry, they manufacture burner, automobile engine, they may manufacture aerospace engine. They should check their result, and for them CFD plays an essential role to predict the emission. CFD also useful in heating, ventilation of building, car, bus, civil aircraft. CFD also useful in weather forecasting, defense and space application. It is also useful in biomedical application to develop their product. Example is ventilation. To see the pattern of air circulation inside the lungs, CFD will help to find out. CFD has hundreds of applications, hundreds of industry have different products to develop and their demand in future. CFD definitely will be helpful and important role for design optimization of engineering product. CFD simulation gives insight into physical parameters such as velocity, temperature, pressure that are very difficult to study using traditional experimental technique. Here I have presented two images. Left image present an actual explosion emerged from oil plant, and we have to find out which direction this smoke will flow, and CFD will plays role to find out this smoke pattern, and the smoke pattern predicted by CFD simulation is quite similar to the actual phenomenon. This implies that CFD would replace experiment up to certain extent. Here I have presented one of the complex problem. It comprises many physical phenomena which are happening at a time. And this is a polarized coal fired boiler. Boiler comprise a furnace. At one side, burner are placed. In burner, air and fuel are supplied. And fuel can be solid, liquid, gas. If you use coal, then you have to use particle phase model. If you are heating the water in water tube, we need evaporation model. There is also evaporation drying of the coal in furnace. And there is also devolatilization of coal, char combustion. There is also turbulent mixing of air and hydrocarbon. We need to use turbulence model. There is also chemical reactions happening in the combustion. There are interactions between turbulence and chemistry chemical reaction. Then we may have to use turbulent chemistry interaction model. There is also radiatory transfer. We have to apply heat transfer formulation. There is also formation of soot, NOx, SOx. These are harmful pollutants. There is also ash formation. For this problem, around 11 mathematical models are required, and each mathematical model has different discretization and different way of modeling. Due to large number of physical variables, CFD problem become complex and it takes lot of time for simulation, and its understanding and interpretation is also difficult. CFD result for this case is presented here. We can find out temperature distribution of flue gas. We can find out the heat flux profile over the water or tube, heat absorbing element like economizer, rear heater. CFD plays very important role. We also learned how coronavirus is was a critical disease. To find out spacing between person, definitely CFD plays an important role. Here one more example I have presented how CFD can help to find out breathing pattern of our respiratory system. Here lungs are expanding and contracting, and it is a problem of fluid and structure interaction. Definitely CFD will play to find out which area oxygen is less, which area oxygen is high. About Advanced CFD course, this information is given on website www.cfdflowengineering. It comprises 12 lectures, 11 tutorial, 11 assignment. There are additional training material like e-books, user guide. We also give additional analysis tutorial for a participant We also provide quizzes. We also provide job opening on WhatsApp group. There is a WhatsApp group is there. Those you have registered, they will get immediate job opening and they will apply as early as possible, and they have more chances to get shortlisted. Those students did assignment sincerely, definitely there is more than 80% chances they will be selected for a job condition, for job or any industrial profile. These assignments are based on industrial problems. We learned a lot. All lecture cover basic and advanced topic related to engineering subject. We also provide framework how to study and how to practice CFD software. You have to build two pillars. One is foundation of engineering subject. Other pillar is skill in CFD software. You must know how to create geometry. You must know how to create meshing with optimum effort. You must know how to simulate in short time without mistakes, because industry need productive work. They want to reduce cost. They focusing on your result, your output. They won't focus how you are good in skill. They want result. Hence this course definitely will help a lot, both engineering subject knowledge and CFD software skill. The fees for engineering student is only 3,500. Those students are doing job, then they have to pay 5,000 rupees. For overseas student, they can pay 7,000 USA dollar via PayPal. We will provide 6 month access to all the recorded video lecture, notes, assignment, ebooks, user guide, ANSYS tutorial, and more, so that your learning will be enhanced and will be a competitive CFD engineer in the market. This is also useful those students who would like to go for higher education in USA and Europe, even those who would like to apply for master Ph.D. in India's top universities like IITs, ISC, NITs. They will get exposure of various subjects. We provide online CFD support. You don't worry about how to install CFD software, how to learn from the scratch. We have also trained non-engineering students. You may not believe, we also train non-engineering students for CFD. The person who has knowledge of 3D animation, we have trained him, and his company provided assistant, and this of 50,000, and he learned successfully how to do CFD simulation of data center cooling. If you are engineering student, if you do this course sincerely, definitely it will be a good competent. You will get more job opening, and the fee for this course is very less. compared to the any other engineering course in India or abroad. More than 100 students and industrial professionals have taken this course. Some students have taken this course twice. Don't miss an opportunity to join this course. To join this course, you have to email on to cfdflowengineering@gmail.com. You will get registration form and fill it. You have to fill this registration form and pay using Google Pay or PayPal and join as soon as possible. Don't wait for getting a job. Learn as early as possible and try to get good job in CFD industry.